From 3D printing to a profitable concrete business. Today, I'm giving you 4 exclusive designs, including a commercial license. I'll show you step by step how to create silicone molds and sell concrete products with massive profit margins. And as a bonus, we're going to build a vibration table together, which is a top seller all on its own. No more excuses. Today we're building your business. I've tossed the sliced files into the 3D printer. And after a few hours, we have our 3D printed molds. You can see all of them here, just the 3 I've prepared. These will be concrete candle containers, either with smooth or ribbed walls. They also work great as planters for succulents, but I'm sure you'll come up with plenty of other ideas for how you'd like to use them. The first real step starts now: sanding. In the slicer, it's best to place the visible seam where it can be easily sanded down later. For prints like these, I actually love using leftover filaments. Since the color of the filament doesn't matter here, it's the perfect way to use up the last few meters of every spool. Today I'm sanding with 400 grit sanding sponges, and I recommend not going any lower than a 240 grit. The support structure comes off and the sanding can begin. I want to give everyone a very important tip here. You only make this mold once, but you can create many silicone molds from it. If you don't sand it well and the layer line or a scratch remains visible, it will show up in every single silicone mold you make and ultimately on every finished product. So take your time with the sanding. Just be careful not to sand one spot for too long, as the filament can heat up and melt. This is what my sand model looks like now. I'm really happy with it. Now we move on to the second step, spraying it with liquid filler. You can apply a slightly thicker layer in areas where there are still scratches or imperfections. After a few hours, the filler is completely cured and can be sanded down easily. It works especially well in combination with water. Done. This looks great, and that's exactly how the final product should look. I'm using double-sided tape to attach my container to the printed base plate. It's better for it to be too sticky than not sticky enough. If the tape isn't strong, the container might start to float in the silicone, which would be a real shame. I've placed it exactly in the center and assembled the entire model. By the way, the smaller container has a tiny hole. This hole will help us take the mold apart later, but it's crucial to tape it shut from the bottom first. There we go. Hot glue is coming into play now, but this time I thought I'd test some strong adhesive tape on the side walls. So I've taped the connecting walls here and was curious myself to see if any liquid silicone would leak out. If it stays sealed, you save a lot of time compared to using hot glue. I still used hot glue on the base plate this time, but I'm actually considering ditching hot glue entirely in the future. The red inner part you see here is designed to save silicone. Silicone isn't exactly cheap, and we want to work cost effectively. The object must adhere very well. It absolutely cannot start to float. If that does happen to you, you can place something heavy on top, like in this example. A vacuum chamber is perfect for getting all the air bubbles out of the silicone. However, it's not a must-have. If you only plan on making a few containers, you don't need to buy one. Many 2-component silicones are self-degassing after pouring. It's not quite as perfect as using a vacuum, but for hobby use, it's definitely enough. A silicone with a Shore A20 hardness is ideal for these types of casting molds. Usually I try to make several molds at once so I can use up all my silicone without any waste. Here I used 300 grams, which was way too much. I'd recommend starting with 200 grams instead. As silicone is the most expensive part of the project. The vacuum pressure forces the air out of the silicone, and as you can see, there's quite a lot of it. Make sure to use a larger container, as the silicone expands significantly during the process. After about a minute, it's ready to pour. I let the air back into the chamber to release the vacuum, otherwise I won't be able to get the lid off. Always pour slowly so the silicone has enough time to push the air out as it settles, preventing any new bubbles from getting trapped. It's also important to pour from only one direction. After curing, I can see that absolutely no silicone leaked out. For that reason, I'll probably prefer tape over hot glue in the future. Since hot glue was still used in this project, I am carefully cutting it away with a utility knife. Now, let's disassemble the model. This is where that small hole in the red object I mentioned earlier comes in. A ball pump works great here. Just insert the needle into the hole, not too deep so you don't damage the silicone, and pump some air in. This pneumatic method is honestly the best thing when it comes to mold making. The bottom comes off, and now for the final step for now, carefully peeling off the silicone. It looks really good. I am very happy with the result. Before we pour the concrete, let me show you how I built my vibration table. I had the multiplex board cut to my specific dimensions at a local hardware store. Most sturdy boards will work, but I chose multiplex. It's a bit pricier, but extremely stable. Mine is about 36 by 30 centimeters. I'll quickly add a small laser burned logo, and then we're good to go. I'll link all the parts in the description in case you want to build one yourself. By the way, you can actually sell tables like this. Professional versions are often overpriced and sometimes even lower quality. So if you source your materials cheaply, there's definitely some money to be made. I'm using 4 rubber feet. To be honest, I went a bit overboard and built this thing almost too sturdy. Smaller, thinner parts would easily handle the weight since we're usually only casting a few 100 grams or a couple of kilos of concrete. These are my shock absorbers. They're very heavy duty and work great with higher weights, though they're almost too stiff for this project. What do you think? Would it be worth 3D printing these parts out of TPU filament instead? That would be a real budget saver. The absorbers have an M8 internal thread that fits the rubber feet perfectly. I've also got 4 small screws and 4 M8 threaded inserts. If I were to build it again, I'd probably scale down to M6. Even M6 would be plenty stable enough to cast up to 30 kilograms. The heart of the table is the motor, equipped with an adapter to regulate the speed. It looks small, but it's more than enough. I'm marking a 6 cm distance from each corner of the plate where the feet will go. Time to drill. The M8 inserts have an 11 mm outer diameter, so I'm using an 11 mm wood bit. Last time I used a cordless drill, but this time I'm using the drill press. 4 holes are drilled in no time. On the bottom side, I am hammering in the threaded inserts. Don't mind the engravings on the wood, I was just testing the speed and power settings of my laser earlier. The motor also goes on the underside. I'm marking the spots and pre-drilling slightly with a tiny bit for the thicker screws. And yes, you can do this entire project with just a cordless drill. A drill press isn't a must. Now I'll screw in the 4 main screws, and the final step is just screwing in the 4 feet with the shock absorbers. It's actually pretty easy once you know the steps. Just 4 holes and a few screws. Now for the test, I usually never need more than 25% of the motor's power. There's plenty of headroom in terms of strength and speed, so it's suitable for larger projects with several kilos of concrete. You can of course customize the surface area to be smaller or even larger. Regarding the concrete, I've started ordering mixed pallets now. For a 1 kilogram batch, this is my go-to ratio. It gives me the best results. Since I already have about 10 kilograms of premixed, I'm just taking out 350 grams, so I don't have to mix every single ingredient on camera and drag out the video. I'm adding a bit of flow agent, not too much, just 1 milliliter for my finished mix. Using a small 2 milliliter syringe makes it easy to measure these tiny amounts. Here we go. The mold is ready. I add the water by feel and just a few drops of flow agent. Mix it all together thoroughly. Since I'm using a different cement now than in my first casting videos, the concrete cures much faster. I have less time to pour, which is why I only prep for 1 or 2 models at a time. The profit margin here, if you don't count your own time, is just fantastic. With 350 grams of concrete, it costs about 35 cents for this container. But since I mixed a bit too much again, I'd recommend starting with 250 grams. My cost would then be around 25 cents per container. You see, the concrete business is extremely lucrative with a great margin, especially if you do it in your spare time. If you decide to spend an evening or two in the garage pouring concrete instead of watching Netflix, the profit is definitely worth it. Now, I'll let it sit overnight to cure. Mine actually sat for a bit longer. Pro tip: it's a good idea to cover the mold during the curing process so the moisture doesn't evaporate too quickly. The concrete mold is ready to come out now. I've already moved on and cast another one. I like to use these leftover silicone sheets as airtight covers. Since the concrete is still slightly damp, I'll let it air out for a moment. Because I'm making a candle today, I'm applying a sealing layer to the inside of the form. When a candle burns, the wax becomes liquid and hot, and you don't want that liquid wax soaking into the porous concrete. That's why I'm applying a solid layer of sealing wax. I'm using soy wax. It's a bit pricier, but much more eco-friendly than paraffin. I'll secure the wick to the bottom with a double-sided adhesive pad. Just make sure the sealant has fully dried first, or the tape won't stick. I have a professional wax melter, but for this small candle, I'll show you how to do it at home without any special equipment. A pot of hot water and a small metal container for the soy wax are more than enough. Soy wax has a low melting point. In summer, it can practically melt in the sun, so it melts very quickly and easily here. In the meantime, I'm heating the concrete container from above. You do this so the hot wax doesn't heat the cold concrete, which prevents the material from experiencing thermal shock. You do the same with glass containers by preheating them well. I'm checking the temperature with my infrared thermometer. It's much better than just relying on room temperature. Ideally, the wax should cool down slowly to avoid crystallization on the cold walls, which would look quite messy, especially in transparent glass. Time to pour the candle. Do it carefully to keep your workspace clean. We'll wait a bit for the wax to solidify and then I can trim the wick. Let's test it out. My concrete candle is burning, guys. And yes, there are quite a few steps until you get to your first candle, but once you have your silicone molds ready and your concrete premixed, mass production from home is super fast. I've linked 2 other cool business videos for you here. Make sure to subscribe or you might never find my channel again. See you there.